Hello, Socrates at Saddlebrook. Welcome to the second in our series of videocasts on the topic Has Science Rediscovered a Creator? In the first videocast, we discussed science and faith and set the stage for the entire series in a two-part discussion. Now, this has been posted on the website, and I urge you to check it out. Today, we start a two-part discussion on the beginning of the universe. In part one, I will take you on an incredible under 20-minute tour of the universe. We need first some understanding of what the universe is before we are prepared to discuss how it got there. So let's start our journey at night in my backyard. Shh. So quiet here at night in Saddlebrook, Arizona. This is dark sky country, and I can see the magnificent Milky Way. Mount Lemmon is right over there at over 9,000 feet in elevation, and nestled on top of Mount Lemmon is Arizona's finest public viewing telescopes. From there, you get a view of the universe that most of humanity will never experience. And from my backyard, I can see the moon coming over the top of Mount Lemmon. I actually saw Jupiter and Mars practically kissing in November of 2020, and I can see incredible sunsets in the west. Does any of that grab your awe and wonder button? I know it does mine. What's been your experience in looking up into the heavens? Does the beauty of the moon mesmerize you? On a clear night, you can see perhaps 2,500 stars with the naked eye. Does that provoke questions about what the stars are? How do they get there? When you scan the Milky Way from end to end, have you ever wondered, what is it? In this session, we're going to put on our Socrates persona, and we're going to think deeply about what science says about the heavenly bodies, what they are, how big they are they moving? How did they get there in the first place? So fasten your seatbelts and I'll take you on an incredible journey of the universe. We'll start with the moon. As you may know, the moon goes around the Earth every 28 days. Most all the planets have moons too, but our moon is very different. It's huge in comparison to the other planets' moons, and it needs to be that big to stabilize the Earth's tilt to 23.5 degrees. That's what gives the Earth its seasons when the Earth goes around the sun once a year. Now, the sun is just an ordinary star, like many of the ones you see in the sky, only it's much, much closer. The sun is mostly hydrogen gas that is continually exploding like hydrogen bombs do, but at the rate of millions of hydrogen bombs each and every second, converting its hydrogen into helium and releasing an unbelievable amount of heat and energy in the process. The sun is just an incredible nuclear furnace. Its core temperature is 27 million degrees. How big is the sun? Well, it would take over 1 million Earths to fill it up. Where is the sun? Right over there. 93 million miles away, far enough so that the heat doesn't burn us up, but at a distance that it takes 8 minutes for that heat and light to reach us, even though the light from it is traveling at 186,000 miles a second. Did you know that all the planets, including the Earth, revolve around the sun, and the sun is the center of the solar system? Now, the sun is just one of those stars in the Milky Way. You know, planet Earth is circling the sun once every year, right? But did you ever think of what that means in terms of speed? We're traveling at 66,000 miles per hour. And the sun is moving too. You see, the sun is located in one of those spiral arms of the Milky Way galaxy, and it's whipping around the center of the Milky Way at an incredible 450,000 miles per hour. Imagine. We can't feel any of that motion. Let's look at the solar system in a little more detail. Now, all 8 planets go around the sun. As you can see, Jupiter is the largest planet. The Earth is one of the smaller ones. What are the planets? Well, basically, they're just burned out cinders of cooled down rock and gas. They do not shine on their own. They just reflect the sun light that's cast on them by the sun. All the planets have moons, but not a special one like the Earth does. There's Jupiter and its moons. Beautiful. Saturn and its amazing rings. The dwarf planet Pluto. A lot of space junk out there too. Asteroids and meteors, as well as spectacular comets that are visited from way out in outer space and come around and visible every so many years. The most spectacular of all, though, object in all the solar system is planet Earth. And we're going to be looking at her in detail next month. Stars? Almost all the stars we see at night are in the Milky Way. You might not have known that. The sun is just one of the stars, as we said, and the Milky Way contains, catch this, over 100 billion individual stars. And the Milky Way is just one of hundreds of billions of galaxies. Galaxies are huge clusters of stars like our own Milky Way. Our closest neighboring galaxy is Andromeda. Andromeda contains over 1 trillion stars and is located 2.5 million light years away. That means that the light coming in from Andromeda, moving at that incredible speed, left there 2.5 million years ago. And we're just seeing it now. Wow. Size of the stars is also mind-boggling. Here's a comparison of the size of the sun. Imagine just one pixel on that screen that you're looking at right now. One little tiny dot, that's the size of the sun in comparison to the star Betelgeuse in the constellation Orion. The closest star, 270,000 times further from us than the sun, Alpha Centauri. The light from Alpha Centauri takes over 4 years to reach us. And still farther out are stars that you might be familiar with up in the Milky Way. The Pleiades, called the Seven Sisters, the constellation Orion with its giant red star Betelgeuse. Now, think deeply on this one. Remembering the speed of light, it takes years for that light to reach us because the stars are so far away. Precisely, it takes 444 years for the light from the Pleiades to reach us. That means the light we see there left there 444 years ago, in the 16th century. The light from Betelgeuse left there 643 years ago. We have to even ask ourselves, are those stars still burning? Isn't looking through the telescope then like looking backward in time? Sort of like a time machine. Yes, it is. And we'll learn the significance of that in part 2. Well, you might be saying at this point, interesting scientific facts, but where's this discussion going? Where's it headed? Well, it was necessary to give you some idea of the astronomical size of the universe so that you will appreciate how both science and faith interpret this data. So hang in there with me for a few more details as we consider one last major observation. What lies beyond the Milky Way? We really didn't know much about this until the 1920s when Mount Wilson Observatory was built in California. And astronomer Edwin Hubble began peering out beyond the Milky Way. Hubble saw clouds of gas and dust called nebula, and he saw families of stars like our own Milky Way called galaxies. He then made perhaps the most remarkable scientific discovery of all time. This discovery blew away most scientists at the time, even Albert Einstein. In fact, science couldn't even fully accept its own conclusions about this discovery until the 1990s. In part 2, I'll tell you the story and how Hubble's discovery has led science to come to its understanding of how the universe began. Here's a picture of the universe that lies beyond the Milky Way. Stare at it for a few moments. It's from the Hubble telescope. The area covered by this picture is just one pinprick of this entire sky. There's more than 3,000 objects in this picture. They're not individual stars. They're almost all galaxies. And since since each galaxy contains hundreds of billions of stars, and this vastness goes on to the very edge of the visible universe, which is over 5,000 times further away than Andromeda. The size of the universe and the number of stars is therefore mind-numbing. In fact, these numbers are so totally intimidating and overwhelming, we have to ask, why such astronomical numbers? What possible explanations could we have for this data? We're going to find out the answers to that question is more determined by one's worldview than by the data. Don't let go of that thought. Remember, naturalism is an atheistic worldview, that nature is all there is. No God is needed. And it's well articulated by Carl Sagan. Who are we, he says. We find that we live on an insignificant planet of a humdrum star lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people, unquote. Well, from the tour of the universe we just took and looking at the numbers involved, you can readily see why he would draw that conclusion. But for people of faith, certainly the three great monotheistic religions of the world who start with a theistic worldview that a creator exists, they see the enormity of the universe and those numbers as something sacred, something to be worshipful about. For people of faith, the prophet Isaiah articulated it so well. I, the Lord, am maker of all things. I stretched out the heavens with my hands. Lift up your eyes on high and see who has created these stars. I call them by name. And because of the greatness of my might and the strength of my power, not one of them is missing. Now, neither of these worldviews, naturalism or creationism, can be proven, but evidence for each worldview can be put on the table, and worldviews can be evaluated and compared. And evidence is what this series is all about. So, what are the explanations for the beginning of the universe? What direction does the evidence point? Come back for part 2 and we'll look at this together. Now, before part 2, however, I want you to put on your Socrates persona and think deeply about the possible answers to the questions. How did the universe get here? There's only 2 possible answers. 1, the universe was always here. Or 2, the universe had a beginning. But if it had a beginning, then the question really becomes what or who began it? Was it a product of nature alone, or is it a product of a creator? So come back for part 2 to see what the evidence says and decide for yourself which way it points. Now, make sure you are subscribed to these video casts. You do not want to miss any of them. You do that by signing up for a free subscription at the Socrates at Saddlebrook website. If you do that, you'll be notified when part 2 is posted, and you'll be able to sign on and view it. So, until next time, keep looking up. Be inspired by the awe and wonder of the universe, and keep thinking deeply. I'll see you back here next time for part 2 when we look at the beginning of the universe. I'm Stuart Orr.